So today we're graphing inequalities, but not any inequalities, absolute values. So absolute inequalities. Okay, that means we're going to combine not only absolute values that we worked on before, but we're also going to start shading in, giving us not just one answer, but many answers. Example, if I write x is greater than 0, is there only one solution or many solutions to this? So if I say x is 1, 2, 3, these are all greater than 0. So these are all solutions. And if I draw this on a number line, if x is 0, we say answers 1, 2, 3. We use a hollow line to draw this, and we can go to the right because these are all my possibilities. And we mentioned before when we were talking about inequalities is that in the real world, solutions are inequalities. You don't just say, hey, you can come to my house exactly at 2, and then you have to leave right away. You say, for instance, hey, come after 2, right? Or call me between 2 and 5. We mentioned roller coasters where you have to be taller than 48 inches. If you're taller than 48 inches, you can ride. But the kicker rides, you have to be shorter than 48 inches. So today what we're going to do, we're going to graph absolute values, and then we're going to stick inequalities on them. So there's going to be shading involved. So if we looked at a previous example, when it comes to graphing lines, y is greater than, let's say, 3x plus 1, m and b. M is 3, so that's my slope. My b is my y-intercept. We graph our b first. We count the slope, 1, 2, 3 over 1. And then we draw a solid or dotted line. Do you guys remember? Is it solid or dotted? Since we can be equal to the line, we draw this as a solid line. Now, we didn't say y is equal to 3x plus 1. We said y is greater than. That means all the y's that are bigger. If you get confused about this part, it's actually, I think you're overthinking it. So put your pencil on the graph and say y is bigger. Would you go up or down when you say y is bigger? When you say y is bigger, that would be up, up, up. So all these values on top of the line, because y is bigger. And that's how we do a shade on the top section of the line. Because it's not just one point is true. It's not just these lines are true, but all these points in between. And this goes not only here, but all the way across the graph. Okay, so hopefully you master this in Algebra 1, and if not, this helped clue you back into the lesson. Now, I'm going to do this graph on my left-hand side, and it says y is greater than or equal to the absolute value of x. So, just like our previous examples, we're going to graph this our traditional way, and then we're going to make a choice which way to shade. So, to talk about graphing absolute values, we said, first, you can either say, oh, I know what absolute value graphs look like. They look like V graphs. You can do that. In this case, that's a basic standard V graph. If not, you can look at it as our form that we mentioned before, m absolute value of x minus h plus k, where h and k is the vertex. Do we have an h value, and do we have a k value for this problem? No. So x minus 0, that's my h, and plus 0, that's my k. And my m is an invisible 1, just like when we were graphing lines before. So we can rewrite this as 1 absolute value of x minus 0 plus 0. If you want, that's the idea that should be running through your head. Because if you look at it in this form, our h value is 0, and our k value is 0, and our m value is 1. So we know the vertex, which is 0, 0, and my slope is 1 over 1. Up 1 over 1. Up 1 over 1. You can do this all day long. And we mentioned, if you remember, we mentioned when graphing the other side, Instead of going 1 over 1, we can go 1 over -1, right? Because we're going the other way. So -1 over 1 is up 1, back 1, up 1, back 1. I'm going to put the graph that looks like this. Now, just to verify this, because this is an inequality greater than or equal to, is this going to be a solid line or dotted line? So it's solid. Oops. Because it's greater than or equal to. We have that equal sign. If it wasn't solid, if it was just greater than, we would graph the line as a dotted line. Okay. Okay. So the cool thing about IXL is that we can graph these pretty quickly. So they want us to put first a dot down, then you're going to put a second dot, and that's how we figure out how we're going to, oops. That's how we figure out how to draw a line. If you want to undo the dot, you tap the dot again, tap the dot, and it'll go away to undo something. So first dot is for the vertex, second dot is for the point, the slope is 1 over 1, up 1 over 1. And then the third part is a shade. Now, let me ask you this question again. If I say y is greater than, if I put my pencil on my graph, which side would be greater? On top or below it? Again, y is greater, on top or below? Well, it seems like it naturally should be y is greater than the graph. So we're going to, oops, we're going to shade on top. And it's actually pretty easy. But you have to make sure you're okay with these skills that we've been building since Algebra 1. We've been graphing lines, plotting points, and we've been shading from inequalities. Let's submit that. Okay, let's look at this next problem. So how much work do you have to do with these graphs? And the answer is none. It's already laid out for you. You have to first find the vertex. Go ahead and see if you can find the vertex. Once you have it, please type in the chat what the vertex is. Anyone know what the vertex is? They have one answer. Do you guys agree with that answer? Great. Thank you for the parentheses. That makes that a point. So remember, there is no h value, so that's going to be 0. And my k value is going to be -4. That's automatically my vertex. It's all about knowing how to read the graph so we can save a lot of time. You could have come up with a table. You could have said x's and y's and plugged in 0 and done all the work. Absolute value of 0 minus 4 is -4. 1, absolute value of 1 minus 4 is -3. Absolute value of 2 minus 4 is -2. We could do all that work. But just like when we graph lines, remember y equals mx plus b, instead of plotting points, we look at the characteristics of the graph and makes it so much faster to graph. So since we know the vertex is 0, -4, I'm going to count 0, 1, 2, 3, 4. I'll put a dot there. The slope is an invisible 1 in front. That's how fast the graph is changing, one step at a time. So up 1 over 1. That gives me the v I wanted. Now, is this solid or dotted? So if I tap the line here, take a look here, it's a very subtle difference. If I tap the line, you can see that changing from solid to dotted. Now, this is less than or equal to, so equal means the line is solid because we can be on the line. Answers on the line are possibilities that are true. And then the last step is to, are we going to shade above or below? Now, as I mentioned before, we said y is less than this graph. So put your pencil on the graph, and which way would be y is less than, on top or below? I'm thinking below. That's it. So let's skip to a harder problem. So this one is similar to our last graph. So our h and k are still going to be 0, 0, because if you look at, there's inside the absolute value, there's no plus or minus. So my h would be 0, my k would be 0. And that 3 there, that's going to become my positive 3 in the end, because all the absolute values become positive. So positive 1, 2, 3 over 1. So for this graph here, let me ask you, is it a solid or dotted line? Solid or dotted line? It would be dotted, right? Thank you. So we tap on the line, changes it to a dotted line, and y is less than the graph. So all the y's are less than are below. Okay, so we can get to harder problems. Let's jump to something that we practiced today. If we take a look at this graph here, just like what we did in Khan Academy, y is less than 2 absolute value of x plus 1. What is my h and k value? My h would be 0, my k would be 1, and my m would be 2. So we plot 0, 1 first. X is 0, y is 1, put a dot there. Count your slope. From that dot, we're going to rise 2, up 2, run 1. Okay. Solid or dotted. And I'm pretty sure you're going to make a couple of mistakes like this. Y is strictly less than the line, so we're not allowed to stand on that line, so it's dotted. And then we're going to shade above or below. Y is less than below. Thank you very much, Lenny. Okay. So for this IXL, it's going to be asking you to get up to 40. Sorry, up to 90. Oh, I already said that. So you guys can practice that. Now, for this problem here, the same idea, absolute value of 4x. So you can move the 4 out because there's no values back here. There's no values back here, so you can move the 4 out. And it's a positive 4, so the positive 4 isn't going to make a difference to the absolute value sign. So that's a very similar problem. We get to something that looks a little bit more gritty. Okay, so for this problem here, I want you to notice something. Y is greater than or equal to absolute value of 4x plus 4. Now this doesn't really look like our standard form. Remember, our standard form is y is greater than or equal to m x minus h plus k, right? So we need x to be alone. So this is what you do. You factor out that 4. So I factor out the 4, so it's y is greater than or equal to 4 absolute value of x plus 1. I factored out that 4. So once we write the 4 on the outside, we see that 4 is my slope, and my h value is not positive 1, but actually negative 1. And my k value is 0. So these can be a little bit tricky, especially when there's a number in front of the x. So h is negative 1, k is 0, put a dot. We said the slope is 4, up 1, 2, 3, 4 over 1. Now, if you want to make sure this is true, I see the point that I dotted was 0, 4. If I plug in 0, will I get 4 there? If I plug in 0, 0 plus 4 is 4. Yeah, that's my answer. If I try to plug in the number on the left side, negative 2, that might be a tricky one. Y greater than or equal to absolute value of 4x plus 4. If you look at my number on my left side here, see this value on my left side? That's x is negative 2. If x is negative 2, would we still get positive 4? If you just want to double check. This is absolute value of negative 8 plus 4 is absolute value of negative 4. And that is 4. It's just a way to double check it. Is this dotted or solid? This is a solid line, and we're going to shade above. Okay. All right. The next IXL you guys have today, and that's going to be only up to 50. So now we're going to mix the two systems together, and you're going to graph them and shade in the right section. So we've already worked on shading different systems of inequality already. So this is more of an advanced topic using two different graphs, one of them being an absolute value sign. So let's go to the first graph. You can pick, look at the bottom, how I can make them highlighted. Pick the one you want to graph first, which is x is greater than -5. So where x is -5, here's -5, and we're going to draw a line, -5. We're then going to graph the second graph, which is y is less than or equal to x. X is, so my vertex is 0, 0, and the slope is 1 over 1, just like what we talked about before. Now, in what sections would it be? Okay, here's the tricky part, okay? So we actually have a lot of parts. We have one on top, we have one corner here, and one corner here, and this whole section here. So which of these 1, 2, 3, 4 sections would I shade? That is true for both these statements. First, let's review the statement. X is greater than -5. So it has to be one of these two sections. Of these two sections, which of these is less than the absolute value? So let me do that again. So IXL is a cool way for allows me to shade it. So let's do the first one. Look at the top, x is greater than -5. So if I use my hand, I say, look, this is my -5 here. Oops. Okay, x is greater than -5. We're on this side of the graph. So I can tap those sides, both those parts. Right? I think we lost it. Let's do this problem again. X is greater than -4. Here's -4. Our graph of absolute value of x is that line here. Now let's decide which way to shade. X is greater than -4. These are my two possibilities. Of these two possibilities, which one is less than the absolute value? And that's going to be right for us. Let's jump to be a little harder. Okay, y is greater than -8. So here is y is -8. Everyone agree? Y is -8. We'll graph the second one, absolute value. Careful about it. We have a vertex, not a 0, 0. That's going to be -7 and 0. Oops. -7 and 0 with a slope of 1 over 1. Now, where could we shade? Let's first look at the first term, or first equation. Y is greater than -8. So these are all the sections that are greater than -8. Now, of all these sections that we shaded, which of these is less than the absolute value? That's below. Okay, so you're going to do that
Is
up
it
to 50.
blue dotted?
Oh, thanks for catching that. You're right. You're 100% right about this line here. That line is dotted. Oh, we got that wrong, right? Great attention to detail, Leah.